You with even odd identities, and you have a table below with some identities that I already wrote out for you. And what you need to do with them is you need to prove them algebraically. You need to use some algebra to show that they're true. And I'm going to help you with the first two, and I'm going to leave you to kind of struggle through or figure out the second two, so the last two columns in that table. So the first identity says that tangent of negative x is equal to minus tangent of x. How are we going to prove this? Well, let's start with the basic definition of tangent, or the basic definition of tangent is the adjacent side, the opposite side over the adjacent side. And when we used that, we found out through the quotient identities, the one where we divide, we found out that tangent of x in general is equal to sine of x divided by cosine of x. So if you don't remember where this comes from, please review quotient identities. Okay, so we're going to use the quotient identity to prove the new identity we're looking at. So I know that this is true. I know that tangent of x is always equal to sine of x over cosine of x, no matter what x I plug in, because this is a proven identity from a previous part in your activity guide. Therefore, now I'm going to substitute. Instead of x, I'm going to use negative x. So I'm going to say tangent of negative x is equal to sine of negative x over cosine of negative x. And why do I know this is okay to do that? Because as I told you, we know the red identity over here is true. It's proven. So we can plug in any number for x, and both sides will always be equal. So instead of plugging in x, I decide to plug in negative x. So therefore, these sides should still be equal. Now, I'm going to keep this side the same. However, on the right side, I found out before that cosine of x is equal to cosine of negative x. So instead of writing cosine of negative x here, I'm just going to write on the bottom in the denominator, I'm going to write cosine of x. Because this denominator is exactly the same as this one over here. This we learned from the previous video. What about sine of negative x? We didn't really speak about it. Well, let's look at the unit circle. Sine of negative x really gives me the same absolute value as sine of x. It's really the same length, right? This length over here is equal to this length over here. If this is A, then this is A. They're exactly equal. However, the difference is that they have opposite signs. So because they have opposite signs, I gotta put a minus here in the front. Because if this is sine of minus x, this sine of x gotta have the opposite sign. Okay? So if this is minus 3, this here will be minus 3. Well, the two minuses gives me a plus 3. So this minus here really is I already have, this is negative, so a minus and minus. So if I have minus 3 and I put a negative in front, I'm going to get a minus 3, while the two minuses will become a plus. So here it is. Instead of sine of minus x, I can put in minus sine of x. Oh, that's kind of cool. Okay, so I'm going to put this minus in front. Tangent of negative x equals, and now I'm going to put the minus in front. It doesn't matter where I write it. But guess what? This thing over here from the red identity is really equal to tangent of x. So I can say the tangent of negative x is equal to minus tangent of x. You know what? The next column in the table is actually easier to prove than this one that I just did. So I'm gonna leave you to struggle through all three columns, not just the last two. Use this as an example and what I did and try to figure out the other three, okay?